Okay, so we've been talking about probability distributions and specifically discrete probability distributions because the random variable can take on 0, 1, 2 whole number values. This is the last page that we talked about in terms of you can use the calculator to figure out your mean, your standard deviation, and your variance of a probability distribution. And the only thing a probability distribution is a distribution of 100% of the probability to the possible outcomes that can happen in an event. And so I would suggest that you take the instructions here for your TI-83 or 84 calculator and use that. First question though, you should ask yourself, is this a probability distribution or not? Well, are all these between 0 and 1? Yep, they are. Do these add up to 1? Yeah, 0.1 plus 0.3 plus 0.5 plus 0.1, those do add up to 1. And therefore you can either use the formulas here or the calculator to find the mean, the standard deviation, and the variance of your probability distribution. Okay, so go ahead and pause the video and try that one more time here, and then I will go on to the next. Go ahead and pause the video and try it. Okay, hopefully you've tried that. Let's talk about the rare event rule. If we are told that the coin is fair, flipping a coin, you 50-50 chance of heads or tails, but then when you start flipping it 1,000 times, among 1,000 tosses, you get 937 heads. What do you think about the coin now? Well, if it was fair, you should get something close to 500, not 937. When you get this much heads out of 1,000 tosses, because this probability of getting this many heads is very, very small, you would start thinking, wait, is the coin really fair? And that actually gets us thinking about hypothesis tests. And that's what we're going to talk about in Chapter 8 a little bit later. But that's the idea behind a hypothesis test. Make a claim, there's a hypothesis, then you do experiments and find out what you actually get, and figure out, well, is this really far away from what it's claiming? If it's far away from what it's claiming, which it is, then the claim is probably not true. Probably the coin is not fair. And that's what this last statement says here. If we do get that many, then we can assume the coin is not fair because we actually got 937 heads out of 1,000 tosses when the probability of that happening is very, very small if the coin was fair. That means the coin is not fair. Okay, so that's the rare event rule. Along the same lines, unusual or unlikely values. Unusual values happen or are greater than 2 standard deviations away from the mean, so above or below the mean. And unlikely if probability is very small, usually less than 5%. And this is consistent with the 2 sigma idea that's associated with the empirical rule. Let me show you what I mean by that. Here is the picture. And the idea here is that if we have a standard deviation, one standard deviation to the left and to the right, that would be just 68% of my population within one standard deviation. If I have 2 standard deviations away, that's 95% of the population. So how much is left of the 100%? 5%, which are over here in these 2 tails, very unusual values. So if I do get something very, very close to the mean, right, then yeah, that's confirming that the mean is what it's claimed to be. But if I get something that's very unusual over here above, then most likely the mean is not what it's being claimed to be. It's probably shifted to the, it should be shifted to the right a little bit, or the other way around, to the left, if I did get something experiment-wise on the left side. Okay, so more than 2 standard deviations means it's unlikely to happen, and that refers to 0.05 or 5% chance probability that the event will happen. Let's talk about expected value. What is the expected value? It's the average value of the outcomes. So you play a game, for instance, this is the usual example that's being used when we talk about expected value. You play a game. If you keep playing it, on average, what is the expected outcome? Are you going to win? Are you going to lose? And hopefully you recognize this formula. The sum of x multiplied by its probability is something you've seen before. That is actually the mean. So the expected value and the mean are exactly the same thing. What's the average outcome? What's the average of a probability distribution? Those are the same things. So let's practice some with some basic examples, and then we'll make them harder. So suppose you, in the first table, you play a game in which you can lose $5 or you can win $5. Those are the only two outcomes, lose $5 or win $5. You can win $5 with 244, with a probability of 244 out of 495. And the probability of losing that $5 is 251 out of 495. Please note that this is a probability because 251 plus 244 do add up to 495, which 495 divided by 495 is equal to 1. To find the expected value, you need to multiply across the expected losses by the probability that you will lose this money, which ends up being negative 2.535. The amount that you can win with its associated probability, multiply that, and you get 2.465. And then add up the last column, and you get expected value is negative 0.07. Well, if those are the expected winnings are actually a loss of 7 cents. The question then actually that begs to be answered begs to be asked and answered would be, is this game fair? And the answer to that is no, because the expected winnings is not 0. Only in the case when the expected winnings are exactly 0, then you know that the game is fair. If they're above 0, positive, that means you have more chances of winning, which is not fair. Again, you might be thinking, wait, that is fair. I'm going to win. No, that's not how probability works. If it's above or below 0, then the game is not fair. If it's expected winnings, the average amount of that you win or lose is exactly 0, then that would be exactly a fair game. So let's try it with another table here. What if you lose $5 with this probability, 37/38, and you win $175 with probability 1/38? You multiply these two, and you get x times p of x. You multiply these two, and you get what value should go there. Pause the video and try to get those values. Okay, I hope that you've tried it and attempted it. We'll write it out here. So the expected value would be, here's expected value, E is equal to the sum of x times p of x, which is the formula for the mean. And from our values, you would get, we lose $5 with 37/38 probability. So negative 5 times 37/38 probability. Plus, you can win 175 with 1/38 probability. Okay? And so if you actually calculate that, you have five times 37/38. So 5, negative 5 times 37, and then divide by 38. You get 4.86, negative 4.86. I'll round to several decimal places. 4.868, like that, plus 175 divided by, or multiplied by 1 divided by 38 would be 4.6052. And if you add those two up, you get negative 0.263 to 3 decimal places. Is this game fair or is this game not fair? It is not fair since this is not 0. Not a fair game since expected value is not 0. Not fair if it's not 0. If it's 0, then it's fair. Okay? So we played those two very basic games. Let's make it a little bit more interesting. Suppose you want to insure a laptop, an iPhone, a trail bike, and your textbooks. And the table below, table 13.8, lists the values of these items and the probabilities that these items will be stolen over the next year. Part A and Part B predict what the insurance company can expect to pay in claims on your policy. What is the expected value? So that's basically asking the exact same thing. And if you go take a look at this table, the laptop has a value of $2,000. The iPhone has, I don't know when, but $400. Trail bike, $600, and textbooks, whoa, $800. The probability of each one of these being stolen is given in this column. Notice that these do add up to 100%, right? These are the only things that can happen if those are the only things that you're insuring. These are the only things that are going to be stolen. Of course, other things can be stolen, but you're not including them in your insurance policy. And then the expected payout by the insurance company is this last column, which is just a product of 2,000 times 0.2, 400 times 0.3, and so forth. Now, to find the expected value, all I need to do is do what? On this last column, add up all of these values. 400 plus 120. So, add them all up. And you get 900. So $900 is expected to be paid out by the company, the insurance company, if on average at the end of the year, by the end of the year. That's the expected value. So then the question is, well, for the year, is $1,000 a reasonable premium for this policy? Does it make sense for the company to actually pay, for the company to charge $1,000, charge you $1,000, if the expected payout is $900? Well, yeah, that's reasonable. Why? Because then the company can stay in business. It will be making a profit of $100 per such policy per year, right? If it actually charged exactly $900, the company would break even with the expected value, and therefore they would not make any money. If it's charged $10,000, that would be unreasonable as well, because the expected value is $900. They would be making a lot more profit off of each such policy than the expected value. The expected value was $900, and it is reasonable to charge $1,000 for this policy. So that's a different context, but you see expected value was used here as well. What's the average amount that the company should pay out? It should pay out $900. Again, granted, these are the probabilities with which these items can be stolen. Okay, a couple more examples. A casino claims to have a fair roulette game. The roulette game limits you to place a single bet on one of 38 numbers on a roulette wheel. They allow only dollar bets per number per roll. If the white ball lands on your number, you get $35. And if it doesn't, then you lose $1. Okay, what is the expected value of this bet? Is this truly a fair game? Now, there's a couple of interpretations of a bet. We're going to make this as simple as possible, okay? What's the expected value, and is this truly a fair game? Anytime you sense an expected value exercise, I highly suggest, I require that you would make a table for yourself. And the table would include these kind of columns, okay? So here's the table. And I've been showing you guys those tables already. So the x variable, what variable values can the random variable take on? And then the probabilities, p of x. Okay? And then the different outcomes would be the rows. So you can win, right? Or you can lose. Of course, you can win different ways if there's multiple ways that you can win, or you can lose multiple ways, and those would be written down here, right? If there was more ways to win or more ways to lose. In our case, there's only winning or losing. Those are the only two outcomes, because either the ball does land on the number that you bet on, or it doesn't. And so the question is, how much do you win? So when I read this, it says your ball lands on, they allow only $1 bets per number per roll. If the white ball lands on your number, you get a total of $35. So a total of $35 includes this dollar bet that you make. So $35 is what you win. But if it doesn't, then you lose your $1. So in my table, then I can write down, I can win $35, or I can lose $1, which I'll write down by writing a -1. Then what's the probability of winning? Well, how many values are on there? The roulette game limits you to place a single bet on one of 38 numbers. So 1 out of 38, if it lands on that value, then you won. The probability of winning then is 1 divided by 38. And here's the nice thing. If there's only two outcomes, win or lose, you know what the probability of losing is. Since this column, probability column, has to add up to 1, then the rest of the probability, 37/38, has to be the probability that's assigned to the losing row. Now to find the expected value, again, do you see how valuable this table is? The table is very valuable. Now you just multiply across the rows. Expected value is 35 times 1/38 plus -1 times 37/38. Okay? And so when we add those two values, 35/38, we have 35 divided by 38 is 0.921, 0.921 to 3 decimal places, plus, and then -1 times 37/38, or just 37 divided by 38 being negative, would be 0.974 if you round to 3 decimal places. So negative 0.974. And if you add these two together, you have 0.921 minus 0.974. You get negative 0.053, like that. So that's your expected value. That's part A. Part B, is it fair? This game is not fair. Not fair, because on average, you would be losing about 5 cents. Not fair, since expected loss is about 5 cents. Okay? That would be the answer to those two questions. So please note in these exercises that we've been going through, in the first example, I gave you the table, I set up the table, and you just needed to calculate by either adding the two values or multiplying across the rows. In the example that followed, I gave you a table. It was a different context, but you needed to do all of the addition. Multiply and then add up to get the expected value, and interpret as well. In the third example that we did, I did not give you a table. We had to create our table. I would expect that you should be able to create your own table when asked this kind of a question on the test or a quiz. And then this last part, I'm not going to create a table, but I'm going to actually ask you to figure out what the probability is as well. Okay? So here it is, parts A through D need to be answered. In New Jersey's Pick 4 lottery, you pay 50 cents. Now that's a little bit different now. That's why I have this exercise here. You pay 50 cents. That means you're not going to get your 50 cents back. You have to pay to play the game. Pay 50 cents to select a sequence of 4 digits, such as 1332, so you can reuse the numbers and so forth. If you select the same sequence of 4 digits that are drawn, you win and collect $2,788. Okay, first question, part A. How many different selections are possible? How many different selections are possible? Well, we have a 4-digit number. Let's write this down here. A. You have a 4-digit number, so you have 1, 2, 3, 4. I'll do this via a slot diagram. How many values can I choose for the first slot? Well, 0 through 9, that's 10 values, and so forth for all the other ones, which means I have 4 zeros. Multiplying across, I have 10,000 possibilities, 10,000 orderings of the 4 digits. So that's part A. Part B asks, what is the probability of winning? Well, only 1 out of 10,000, right, would be the probability of winning. So probability of a win would be just 1 out of 10,000. Part C, if you win, what is your net profit? Now that's a little bit trickier because it says here that you will win $2,788, but at the same time, remember that you paid 50 cents to play the game, so you don't get that back. $2,788 minus the 50 cents means that your net winnings are, so net winnings are $2,788 minus 50 cents, which gets you $2,787.50. Okay, and then part D asks, what is the expected value? Well, parts A through C kind of set everything up for you. When you make a table to find the expected value, you write X and P of X for your columns and the different outcomes as rows. Well, in this case, either you win or lose again. For win, lose. What can you win? Well, you can win a total of $2,787.50. Notice that's the net profits. With what probability? You will win that with 1/10,000th of a probability. How much do you lose? If you don't win anything, you lose your 50 cents. With what probability? This is a tricky part. Remember, the column of probability has to add up to 1. So 9,999 10,000ths would be that probability. And then you just multiply across. So you have the expected value is equal to 2,787.50 times 1/10,000th, and then plus negative 0.50, negative 0.5, times 9,999 divided by 10,000. And so that would get us our expected value. So if we do this on our calculator, we would enter in 2,787.50 divided by 10,000, and then subtract that from that, I would subtract the rest of the value. So if I enter that in, minus or plus negative 0.50, 0.5 times and you get a total of negative 0.2212, negative 0.2212, or about 22 cents loss. So is it a fair game or fair lottery? No. On average, the lottery game, the system, cashes out 22 cents per such person who plays this game. So not fair game. Okay? Hopefully these examples have been helping you understand what expected value is, the fact that it's actually the mean of the probability distribution. Again, always make a table for yourself. There will be examples in your homework that you can practice, and I hope that you guys gain a lot more intuition from these videos. In the next section, we'll actually talk about binomial probability distribution, and that would be the example of a discrete probability distribution. Okay, get to some homework.